I want you to find the equation of the tangent line to the given trigonometric function f of theta equals to 4 times sine of 2 theta plus 1 at the indicated value. So we have theta equals to pi. So what kind of picture should you have in your mind? So we have a function. So let's say the function is a curve. I will just draw a random curve like that. I'm not saying this is the graph of the given function. Just imagine that there is a curve. Okay, just in your mind, just picture a curve in your mind. And then they give you a location where theta is equals to pi. So let's say that is at this point. The question is asking you to do two things. Number one, tell me the slope of the curve at this point. Then you have to find the first derivative. And then second, tell me the equation of the tangent line. So this is a point, and then there is a tangent line at this point. We have a line touching the curve at this point. The slope of the tangent line. So this is tangent line. And then this is f of x. The slope of the tangent line is equals to the slope of the curve at that point. So at that point, can you tell me the exact location of this point? So to find the exact location, which is the x and y coordinate, you have to plug in the given value first. So f of when theta is equals to pi, what do we have? We have sine 4 times sine of 2 pi and then plus 1. So sine of 2 pi is equals to 0, right? So we have 0 plus 1, that is equals to 1. So the point, the location is when theta is equals to pi, y is equals to 1. We know the location. Next, find the slope at this location. So to find the slope, you have to take the first derivative. So f prime of theta, that is cosine of 2 theta, right? And then times 2 by chain rule, and then the 4, no change. The derivative of 1 is equals to 0. So that gives you 8 cosine of 2 theta. What is this? This is the first derivative. So this is one function to describe the slope of the given function at any x value. Okay, the given function is a curve. This is one function to describe the slope of the curve at any x value. And then to be specific, what happened when theta or when x is equals to pi? Well, when at that point, then you have to plug in pi. Then you have 8 times cosine of 2 pi. So cosine of 2 pi, that is equals to x is that is equals to 1. So you have 8 times 1 equals to 8. This is the slope of the tangent line at that point. At point theta, no, not theta, at pi, comma 1. And then to build the tangent line, you will need to use the point slope form. So point slope form, which is y minus y1 equals to slope times x minus x1. You study that in elementary algebra, intermediate algebra, and pre-calculus. And then we have the point y minus 1 equals to slope times x minus x1. So this is, they usually ask you to put this in a slope-intercept form. So y is equals to ax minus a pi, and then you add 1 to it. And then to make this looks like y equals to mx plus b, which is the point slope form. So that is called the point slope. I mean, not point slope form. This is called slope-intercept form. Slope-intercept form. You will have to do this. Y is equals to ax. We forced to put a plus in here, and then we group everything else in this parenthesis. If so, then you have a minus a pi, and then minus 1, because after you distribute the plus, actually plus 1. Yep. And then this one, the slope is equals to 8. The y-intercept is when x is equals to 0, y is equals to negative a pi plus 1. You know what? Oh, no. Huh. You put a parenthesis. You put a plus. Yeah. You put a plus. Yes. You put a plus. So plus, that becomes minus a pi and then plus 1. Yep. There we go. So everything is fine. No need to correct anything. So that is also the end of this video. If you like it, give me a like, share, and subscribe. And I will catch you all in the next lesson. Peace.